here's another possibility. In actual fact, this wasn't time at all. These are layers of mud. There's one layer of mud, a missing layer of mud, and a red layer of mud. Whereas here we have a black, a yellow, and a red layer. Let me explain this. I have 3 buckets of mud here in the front. One contains black mud, the other one yellow mud, and the other one red mud. Now, I take this huge bucket that I have of black mud, and I go, whoosh, and I spread it all over this hole. And then I take my bucket of yellow mud, which happens to be a small bucket of mud, and I go, whoosh, and I just spread the front here with my mud. And then I take another big bucket of red mud, and I go, whoosh, and I spread it over the hole. Now I have, in the front here, eventually when it dries, I make a cut. How many layers have I got? 3. In the back there, I make a cut. How many layers have I got? 2. Aha. So in the back there, obviously what happened is millions of years of erosion took the middle layer away, right? Right? Or would you perhaps agree with me, I didn't have enough mud to get to the back? You see the difference in the philosophy? The one requires time, the other one talks about mud. Now, which one is right? The Bible says there was a flood, a worldwide flood. That's what the Bible says. Now, if that is true, you would expect a lot of mud on earth. And do we find a lot of mud on earth? Yes. Everything is mud. Marine sediments here on this earth. Where should they be? In the bottom of the ocean. There's not enough there to account for any of this time that has gone by. It's all sitting on land, which is all kind of upside down. Now, here are some scientific publications. 20 million years of weathering and erosion under varied conditions, and then he says, the survival of these paleoforms is in some degree an embarrassment to all the commonly accepted models of landscape development. Here's a scientist that says, you know, we have a problem. All of these mud layers are there, and erosion is taking place all the time, and look at what we have. Everything is still there. Actually, it should be gone several times over. Why is it still there? So we will be looking at erosion between the layers because they were the surface of the earth. Why don't we see it? There's no evidence of it. It's just doesn't make sense. This is what we call a turbidite. Now let's have a look at an alternative model. This is what is an underwater mud flow. You know, when water is muddy, we say it's turbid water. It's muddy. Now, a turbidity current is an underwater mud flow. Now, in 1929, there was an earthquake in North America, and a piece of the continental shelf broke loose, and it roared under the ocean, breaking cables as it went, so they knew exactly how fast this mud was going. It was just going at a tremendous pace. After 3 hours and 3 minutes, it was 300 miles out to sea. That means that this mud was traveling at a speed under the water of 100 miles an hour. Now imagine if you were a little creepy crawly or a fish swimming lazily at the bottom of the ocean, and a wall of mud as thick as this wall over here comes roaring towards you at 100 miles an hour. What would happen to you? You would just be fossilized in an instant, right? Now this is what happened. Notice that we have a model over here. Imagine this is the surface of the earth, largely extended. There's no mountain on scale that would be this high. And everything's underwater, and now there's an earthquake over here, and some mud is beginning to flow. Let's see what would happen. There it flows. Watch how it comes over the hills, into the valleys, over the top. And then it's going to settle down. And notice what it does. It's very interesting. It fills in the valleys while forming a layer over the hills. And this is soft mud, soft mud. Now we're going to put another layer on top of this while this is still soft mud. We're not going to stick around for a few million years waiting for this to turn into stone, okay? We're going to do it right now. While this is still mud, we'll have another earthquake in another place with a different color mud, and boom, there it goes. Watch how it comes around the corner, swirls clockwise. Do you see that? Goes down the hill, up the other side, and does the same thing. Now, do you think it's possible that you could whip some of the bottom mud into the top mud layer when it goes around the corner like that? Do you think it's possible? Possibly, yeah. Here's another one. Look, wham! Take some of the bottom layer, put it in the top, maybe. And then you settle down. And we're not going to wait a million years. We'll just let it settle. And then put another one on top. Notice the valleys are getting fuller and fuller and fuller. By the way, that's what it looks like at the bottom of the column, between the Cambrian and the Precambrian. That's what it looks like. Another layer. And another. And another. And now it's getting pretty flat. And now they're just rushing along nicely, one on top of the other. And then we have a closer look. What do you see? You see one layer on top of each other, and what are the contacts like? What's the contacts like? Flat. And especially on top, everything is flat. And can you see that here and there, for example, there's a little bit of mixing of the bottom layer into the top layer. Okay, if we go a little bit closer, notice what else we'll see. All right. If you look carefully, you will see that in this layer, from there to there, the coarser material, the heavier stuff, is at the bottom. Why? Because it's heavy and it settles out. And the finer material is at the top, because it's lighter and it takes longer to settle. So this thing is graded coarse to fine, which is what happens in water. Now, if this layer had to form over millions of years with then a rain and then a drought and then a rain and then a drought and all these things happening, would the whole thing be jumbled up or would it be graded coarse to fine? It would be jumbled up. If it's graded coarse to fine from the bottom to the top, what does that mean? That this layer formed how? Boom, catastrophically. All right? So if we go into nature and we have a look at them, here we are in the Swiss Alps, hundreds of these layers, one on top of the other. So it's just one after the other. Here we have some in Texas, and they've been lifted up. And you can drive to any of these areas in your country, you'll see beautiful examples. They were, of course, first flat, then they were lifted up later. These are all turbidites. How do we know? Because they're graded coarse to fine. Here are huge ones, big ones, showing tremendous activity. Here's another one. Notice the coarse material is at the bottom, then it gets finer, and then you have the fine mud over there. There are even some ripple marks saying that this happened underwater. And there's the next one, the coarse material to the fine material. Here's one in Australia. This one is in New Zealand, sorry. There you have the coarse material at the bottom. You'll see the pebbly, grainy stuff, the water lines, and then the finer stuff, and the next one starting on top. So how did they form? Slowly or quickly? They had to form just like that. These are mud layers that form just like that. Now, if you go to the Grand Canyon, you'll find a fascinating thing. From the bottom to the top, the whole canyon is graded coarse to fine. Wow. That means that the whole thing must have happened in a very short period of time.